Welcome to Master Builders Online Academy. A very online academy that teaches all the tips that you need to become a guru in any calculation at all. Yes, you heard me right. In this channel, we'll unveil secrets that will help you balance your mental capacity. So, if you are new in this channel, do consider subscribing to our channel and make sure you turn on the post notification bell for more exciting videos. Yes, guys. You are welcome, you are welcome, you are welcome, you are welcome. I'm super excited because you are the one watching this video at this very point in time. You know what? This video has been designed and arranged to help you gain mastery in this course. Now, in this video, there are so many principles I will be unveiling to you. Open your eyes to see things that will help you become masters. Yes, I know you have been waiting for that moment where you can solve problems effectively on engineering mechanics without any stress. Guys, I am here to teach you all the steps by steps. In fact, I will hold you by the hand and walk you through the processes involved in solving any problem in engineering mechanics. All you need to do, guys, is to ensure that you do not skip any part of this video. This is because every bit of this video is encrypted with principles and laws, boundary conditions that will help you gain masteries if you are able to deploy them. Guys, is this offer not wonderful that you are getting for free? Yes, I am here to unveil all the principles. But all you need to do is to avoid every unnecessary distractions. Because when you are distracted, you will not be able to maximize all the laws, principles, and boundary conditions that I share in this video. Then finally, if after watching this video at the first time, you have questions to ask or you are not clear with some certain principles and law, faith comment by hearing and hearing. So guys, I urge you to replay the video over and over and over again until it becomes part of you. It is very, very possible. Then if at the end of replaying the video over and over and over again, you have questions to ask, guys, don't hesitate. That is why I'm here. Slide to the comment section and make your questions known to us. We are very, very good in answering questions and solving engineering problems. So you are not in the wrong place, you are in the right place. In our previous lessons, we looked at what engineering mechanics is all about, the parts that are involved in engineering mechanics. We look at the types of engineering mechanics, the classification of engineering mechanics. We equally looked at loads, type of loadings. We looked at forces, the type of forces. Now, in this video, we equally looked at the laws that are applicable in handling force problems, solving problems on forces effectively. In this video, guys, I will be implementing those laws we stated in the previous lessons. Now, if you are excited to learn these principles, how they have been applied in solving engineering and life problems, quickly let's hit on to my marker board as we begin to solve problems one after the other. Now, very quickly on the board, we are looking at composition and resolution of forces. Mainly for this video, we will be looking at 2 or 3 forces acting on a system or at a point, as the case may be. Now, on the board, we have problems and solutions. Now, this is problem number 1. Yes, I call it problem because we are problem solvers. So, our interest is to what? Provide solutions to this particular problem. So, my aim is not to solve thousands of problems for you, but my aim is to help you understand the principles that when you know these principles, you can solve as many problems that comes to your table. Yes, as many problems that comes to your table. All you need to do is to understand principles that what I've always told you guys, when you understand principles, you become a principal. And when you understand boundary conditions, guys, you will not overstep your boundaries. Now, the problem we have before us is that two forces of 200 Newton and 150 Newton are acting at a point. Full stop. What is the resultant of these two forces if the angle between them is 60 degrees? So the first thing you always do, put down the solution. Then we say, given that, you need to list all the given parameters. Now the first parameter that is given is F1. We know this to be what? 200 Newton. Now F2 is given as what? 150 Newton, because these are the two forces. So the first force we take it to be F1, force 1, while the second we take it to be what? F2, force 2. Then another thing that is given here is that the angle between them is given to be 60 degrees, while we are asked to find the resultant. This is the first step. Now that we have been able to release the parameters involved in this particular question, which include the known and the unknown parameters, the next is to know if I am to find out, given two forces, what law do I apply among the laws of resoluting forces? Remember that we mentioned that forces can be resolved using Pythagoras theorem. We equally mentioned that forces can be resolved using Lami's theorem. We mentioned that forces can be resolved using parallelogram law of vectors. We equally mentioned that forces can be resolved using resolution method. About 4 to 5 methods that we mentioned. Now guys, which of these methods should we apply here? The question is answered this way. The first thing you need to do is to identify the number of forces that you have. Anytime you have two numbers of forces acting at a point, there are two main theorems that you make use of. The number one is the Pythagoras theorem. The number two is the parallelogram law of vectors. That means this question we have on the board can either be solved with Pythagoras theorem or the parallelogram law of vectors. Now guys, when should I use parallelogram law of vectors? When should I use the Pythagoras theorem? Remember, Pythagoras theorem is only used when the angle between the two forces is exactly 90 degrees. Are you there? So you only make use of Pythagoras theorem when the angle between the two forces that you are given is exactly 90 degrees. But when we look at this question, we find out that the angle that we are given is less than 90 degrees. And we mentioned that anytime the given angle between two forces is less than 90 or greater than 90, it is suitable to make use of what? Parallelogram law of vector. So when you have an acute angle between two forces or obtuse angle between two forces, you make use of what? Parallelogram law of vector. So if I state that in this question we are making use of parallelogram law of vector, then you have no questions to ask. That is why I mentioned you must watch this video bit by bit. There is no need skipping any part of this video, otherwise you will skip important principles that will help you gain mastery. Now, if this is taken, now the next thing is, if I am to use parallelogram law of vector, knowing fully well that the angle between the two forces is less than 90, what should I do? I need to bring out a schematic diagram or a rough sketch to represent these forces, then deduce my resultant from there. Now, let's quickly do this. Anytime you have two forces, one of the things you do to make it easy for you is to assume that one of the forces is a horizontal force. So let's assume that this is where the forces are acting. I have a horizontal force, which is 200 Newton. Now all I need to do is I will measure angle 60 from this horizontal force, which will be somewhere here. So this is angle 60 degrees, and this guy becomes 150 Newton. These are the two forces. This is the angle between the two forces, and this is the point where the two forces are acting. Now the next thing is what? Since we already know that we are making use of parallelogram law of vector, all we need to do is to extend the line of actions of these forces. You remember that parallelogram is actually what? A rectangle that is having its vertical line slanted. And that's exactly what you have this way. So I will transfer this line to this end and extend this line in parallel force, and I will equally do the same here in parallel force. Alright. Now in this case, remember that the resultant force must be in between the two active forces. So that if these are the forces, then the resultant force will come out in between the forces. This becomes R. Now also remember, since we have a line of action that we can extend this guy beyond this point, such that the angle here is the same as the angle here, 60 degrees. Now remember that now that I know that this angle is 60 degrees, I can obtain the angle here. Why? The theory, one of the theories in geometry states that the sum of angles on a straight line is 180 degrees. So therefore, angle here plus 60 must be equal to 180. Then if I make this angle here solid of formula, I will have 180 minus 60. And if we remove 60 from 180, guys, we will have 120. So automatically this guy is same thing as 180 minus theta. And remember that theta is equal to 60 degrees. So if we remove 60 degrees from this guy, automatically that point would have given us 120. Now, fully well, we can now pick one of these symbols. Alright? Remember, this is the resultant, so we can pick either the top section of this figure or the bottom section of this figure. Now, if we pick the bottom section of this figure, automatically we will have this sketch as. This is what we'll have this supposed to be. This becomes the resultant. This becomes F1, which is 200. And now this is the direction of the resultant. While this guy is now 120 degrees, this is 150 Newton. Remember, just mentioned that 180 degrees minus theta is the same thing as 180 degrees minus 60 degrees. And this is equivalent to 120 degrees, which angle we have here. Now, looking at this, anytime you are making use of parallelogram law of vector, you make use of cosine rule to obtain the resultant. Now, remember this is parallelogram. So now using cosine rule, recall that resultant is equal to F1 squared plus F2 squared minus 2 F1 F2 cos 180 degrees minus theta. Now remember that cos 180 degrees minus theta is now 120 degrees. Automatically, we will now substitute into this equation. When we do this, this becomes r squared is equal to 200 squared plus 150 squared minus 200, 150 cos 120 degrees. Now when we move further, r squared becomes 40,000 plus 22500, then plus that 2 multiplied by 200 would have given us 400. 400 multiplied by 150 would have given us 60,000, and 60,000 multiplied by cos 120, everything here would have turned to plus 3,000. 30,000. So when we add up everything that we have here, r squared is equal to 2500. Now, to obtain the resultant, you now take the square root of both sides. Then R is equal to the square root of 92500. And when you put this in your calculator, you have 304.14 Newton. This is the resultant force. It's as simple as this. Now, remember, what do you need to understand here? Anytime the angle between two forces is less than 90 or more than 90, you make use of parallelogram law of vector to solve such problems as long as the forces are 2 and the angle between them is less than 90 or more than 90. I hope you have gained a lot of values from this lesson. Now let's dive into question number 2 very shortly. Now guys, welcome back to this session. Now we have question number 2 on the board. Now we have two forces of 300 Newton and 400 Newton are acting at a point. Full stop. What is the resultant of these forces if they are acting at right angle to each other? If they are acting at right angle to each other, that means the angle between these two forces is exactly 90 degrees. So all we need to do is to put that as solution. Given that F1 is equal to 300, F2 is equal to 400 Newton. Now, theta, which is the angle between them, is 90 degrees. Then we are asked to find the resultant. Is this not simple, guys? So simple. Principles makes you principal. Now look at it. The first thing you need to understand is that in this question, we have two forces acting at a point. And we remember that anytime two forces are acting at a point, it is suitable to either use Pythagoras theorem or parallelogram law of vectors or of forces. Now, what conditions do we need to meet before we can apply Pythagoras theorem or parallelogram law of vector? We state that when the angle between the two forces is exactly 90 degrees, it shows that Pythagoras theorem will help us obtain the resultant force. That is to say, now that the angle is exactly 90 degrees, Pythagoras theorem will be suitable for this question. All that we need to do is to state Pythagoras theorem. But before we have that done, guys, we will need to have a rough sketch of how these two forces are acting at a point and thereby reveal the resultant force between these two forces. Now, this is the point where the two forces are acting. So one is acting in the horizontal direction, which is 300 Newton, while the other is acting in the vertical direction, which is 400 Newton. This is it. Now the angle between them is 90 degrees. Now if I take a resultant here, if I extend this guy, this becomes my resultant. This is the resultant. Then if I have this guy, remember this is angle 90. Now if this is my resultant, this value here is exactly 400. And this guy is 400. Also, why this guy here is 300. So all I need now is I have something of this nature. This guy, this is Aaron, this is F2, and this is F1. So in using Pythagoras theorem, that R squared is equal to F1 squared plus F2 squared. This is it. This is your Pythagoras theorem. Now all I need to do is to put in the values, then I move ahead. Now remember that r squared is unknown. Then f1 is 300 all squared, and this guy is 400 all squared. Now if I square 300, we then have that r squared is equal to 9,000 plus if I square 400, we will have this as 16,000, which would have given us what 160,000, while this guy is 90,000. Now guys, this becomes r squared is equal to, when we add 90,000 to 116,000, we will have this guy as 250,000. All we just need to do here, guys, is to find the square root of 250,000. Now, r becomes the square root of 250,000. And the square root of 250,000 would have given us what? 500. This is the resultant force. So take for instance, you are equally asked to find the direction. How will you obtain the direction? Remember that this is the direction of the resultant. So you can equally make use of this if this is the direction of resultant force. We have that tan theta is equal to what? F2 over F1. Why is it this way? Remember that it's always vertical over horizontal. The vertical force divided by horizontal force, or tan theta is equal to opposite over adjacent. And it happens that F2 is the opposite, while F1 is the adjacent. Are we there? So we put this down. Then theta becomes the tan inverse of F1 2 over F1. Then theta becomes the tan inverse of 400 over 300. This cancel this, then whatever we have here becomes the answer. So the tan inverse of 400 divided by 300 is 53.13 degrees. This is the angle of the resultant force. So guys, you find out that these problems are always easy to solve if you can identify what is wrong and identify how to fix what is wrong. Like I just mentioned, anytime you have two active forces acting at a point and you are asked to find the resultant, it is either you make use of parallelogram law of forces or you use the Pythagoras theorem. Now, when should I use Pythagoras theorem? When should I use parallelogram law of forces? You use parallelogram law of forces when the angle between the two forces is less than or more than 90, which is respectively with what? Acute and obtuse angle. But when the angle between the two forces is exactly 90 degrees, guys, you make use of the standard Pythagoras theorem. I hope you have gained a lot of values from this particular video. If you are yet to subscribe to this channel, please do consider subscribing to our channel and ensure you turn on the post notification bell. Don't forget to share this video. Let it go viral. Share this video, like this video, and make your positive comment at the comment section. We love you. Very quickly, let's slide down as we begin to look at question number 3. Now guys, welcome back to another session with me. This is part 3 of this problem session. Now we have question number 3 on the board. Problem 3. Now the question is, the pulley shown below is free to ride on the supporting guide wire. The pulling shown below is free to ride on the supporting guide wire. If the pulley supports a 160 Newton weight, what is the tension in the wire? Now, this is the system that is drawn. Take for instance, we can assume this end to be the roof level. Okay, this is the roof level. Let's assume this is a fan connected with two wires suspended. Remember that this object is suspended above the ground level. Now, for this 116 weight to be suspended at a height above the ground level, definitely this line, this rope labeled as wire must have a particular strength to be able to carry this load of 160 Newton. It is very, very clear. Now, remember that anytime you are solving a system like this, the first thing that is required of you is to have the free body diagram drawn. So you draw the free body diagram, then you can make every other steps that is required. Now we have solution. To obtain the free body diagram of this particular structure, we will need to obtain what direction is this load heading to. Remember that this load is trying to fall down. That means the direction of the load, if this is the point of the pulley, the direction of the load is this way. It's acting downward. The load becomes 160 Newton. At this point, I have a rope at this angle, then I have another rope at this angle. Remember, this is free body diagram. Now, for this object or this weight pulling itself down to be suspended at this level, it shows that these wires are acting upward. Then, the direction of this rope becomes something like this, while this other guy becomes this something like this. Why we call this the tension 1? We call this tension 2. Now, we come back to our general session. Remember that anytime you have three forces acting at a point, there are basically two theorems that you make use of in solving the unknowns. One is the Lami's theory, the other is resolution of forces. In this case, you cannot make use of Pythagoras theory, you cannot make use of parallelogram law of vectors. Those two laws we stated that they are only applicable when you have two forces acting at a point. Now, in this case, you can liken this to the three forces. Okay? So we cannot make use of Pythagoras theory, neither can we make use of parallelogram law of vectors. So we can only make use of Lami's theory. And remember that Lami's theory is only used for three-member forces. So in this case, I have three forces. And for you to be able to make use of Lami's theory very well, you must be able to obtain the angle between the forces. In other words, I need to obtain the angle here between these two forces. I need to obtain the angle here between these two forces. I need to equally obtain the angle here between these two forces. How do I have this done? Now, let's come back to the given structure. Remember that from this given structure, the angle here is 20 and the angle here is equally 20. Now, let's assume we want to deduce a horizontal line here to create an x-axis. All right? Remember that angle here is alternate to this angle, which shows that this is equally 20 degrees. Remember also that angle here is alternate angle, which shows that this is 20 degrees. Now, the angle between this end and this end would have become 90 plus 20. Remember, if this is horizontal line and this is vertical line, the angle between them is 90 degrees. That means this would have given us 20 plus 90 as the angle between this tension and this weight. So when we add this together, this will have given us 110 degrees. This is the angle between the tension 1 and the weight. We are done with that. Now next is to obtain the angle between tension 2 and the weight. Remember, if here is 20, angle here is 90. That means we equally have 20 plus 90. And when we add 20 to 90, we equally have 110. Very, very interesting. I hope you are gaining massive values from this lesson. Very simple if you understand the principle. Lastly, What do? I need to obtain the angle between this end, which is between the two tension, tension 1 and tension 2, which will be very, very easy. Remember that the sum of angle on a straight line is equal to 1. So if I call here x now, it shows that 20 plus x plus 20 must be equal to 180 degrees. Angle on a straight line, this is 20 plus x plus 20. And now remember that x will have given us 180 minus 20 plus 20 is 40. And as 40 crosses from left to right, it becomes minus 40. And when we remove 40 from 180, we have this as 140. The angle between these two guys is 140 degrees. Then another person can say, no, I don't want to make use of this. Now that I've already obtained two angles from these three angles at a point, I can make use of the sum of angles at a point. How will you have this done? Remember that the sum of angles at a point is equal to what? 360. So I know this, but I don't know this. So we have 110 plus 110 plus the third angle, which is unknown. The sum of these three angles must be equal to 360 degrees. This plus this will give us 220. That means x is equal to 360 minus 220. When we remove 220 from 360, we will equally have 140 degrees, which we already obtained here. So whichever way, as long as you are good with geometries, you should not have issue with this aspect. Now, if this is stated, the next is to state the Lami's theorem. Now, using Lami's theorem, Using Lami's theorem states that this tension over the sine of the angle opposite the tension. So if I take this tension now, the angle opposite this tension is 110. Then I will have sine 110 degrees is equal to. Now, if I take tension 2, T2 over the angle opposite the tension 2, and the angle is equally 110. I have sine 110 degrees. Then equal to. Finally, if I take the weight, which is 160 Newton, the angle opposite this weight is 140. Then I have sine 140 degrees. Now that I have obtained these three ratios, from here I can decide on whether to find T1 first or find T2 first. To find T1, I will take this ratio and a ratio that is completely known. Remember that in this ratio, we have only the denominator known. In this ratio, we have only the denominator known, but in this ratio, we have both the numerator and the denominator known. So anytime I am picking two ratios at a time, I will pick one ratio where I have one unknown, and I will pick another ratio where I have no unknown. Now, if this is taken, then I will decide to find T1. So to find T1, I will take the first ratio, which is T1 over sine 110 degrees, which is equal to, then I will take the other ratio, which is completely known, 160 Newton all over sine 140 degrees. Now, when you look at this equation that you have here now, you have only one unknown. Then you can make T1 the subject of formula, which would have had as T1 is equal to cross multiply this guy here, this denominator, we just multiply this numerator and you are good to go. So we have 160 Newton multiplied by sine 110 degrees all over sine 140 degrees. When you multiply 160 degrees by sine 110 divided by sine 140, your answer would have been 234 Newton, approximate value. This is it. Now, to obtain T2, I will do the same thing to find T2. This would have given us what? T2 over sine 110 degrees is equal to, I will equally take this ratio. Or I can take this first two ratio. Alright, there is something that we explain here, but let's work it out. Then later that we explain something that is fishing here. Okay, now in this case, I will have 160 Newton all over sine 140. Now, to make T2 the sort of formula, we just multiply the denominator of this ratio by this numerator. Then we have T2 is equal to 160 Newton multiplied by sine 110 from the denominator of T2 all over sine 140 degrees. So T2 would have been equal to what? 234 Newton. This is what we have. Now you find out that when we solve this problem, we have equal results. In other words, T1, the tension here is T, and T1 is equal to T, and T is equal to T1, T1 is equal to T2, all is equal to 234. So the two tensions are the same. Now guys, what do you get to know here? Now the important thing you should note here, why the answer for tension 1 and tension 2 are the same is because they all make equal angle with the roof level. Let's, for instance, when we started this analysis, we stated that let's assume we take this guy as the roof level. Now, when you look at this tension, it's making angle 20 to the roof. When you look at this tension, it's making angle 20 to the roof. As long as they both make equal angle to the surface level or the roof level, they will have equal tension. You only have variable tension when one angle is less than the other or when one angle is greater than the other. Now equally, when we come to this point also, you find out that the tension 1 make an angle of 110 to this load of 160 Newton. And the same way, this tension 2 is equally making an angle 110 with this one. As long as they are making equal angles with the load, definitely they will have equal power. They will have equal magnitude. They will have equal strength. So the strengths are the same, or the tension are the same, because of the fact that the two tension or the two wires made equal angles with the surface level, which we assumed as the roof level. Hope guys, you are gaining massive value. Or at this point, guys, I know you have gained a lot of values without paying a dime. Please subscribe to this channel. Don't forget to share this video. Let it go viral through you, so that at the end, those people that got the link from you, we appreciate you for what you have done for them. So please do not be selfish with this video. Let your friends, classmates, colleagues, and other students within the university cycle where you are and outside the university cycle where you are get to access this content. It will help them just the same way it has helped you. I know you have gained a lot of values. Very quickly, we shall be looking at question number 4. Hello guys, welcome back to another section with me. This is the very fourth problem on engineering mechanics. Now, on the board we have problem number 4. And as such, the question is, two cable wires support a load of 850 Newton weight as shown in the figure below. Let me read it again. Two cable wires support a load of 850 Newton weight as shown in the figure below. Now, determine the tension in the cables. Don't forget, now that this is the weight, this is the figure we are given. Now, this is the weight that is being suspended above the ground level. Remember that for this object to remain at rest at a certain height above the ground level, these guys must be doing something. there must be response of this guy for this other load to be at equilibrium. So we are actually looking for the capacity or the strength of this cable that's able to suspend this load of 850 at a height above the ground level, even when this load is being influenced by the gravitational force. Remember, every object that is suspended above the ground level is always being affected by the gravitational force. So for these two guys, which are these two cables, to be able to suspend this weight above the ground level and remains at equilibrium, something must be happening here. What is happening here and here is what this question says that we should look for. What could be the strength of this wire AB? What could be the strength of this wire BC? To be able to put this object above the ground level, and yet gravitational force is unable to put this weight down. To obtain this guy, the first thing you always do is to draw the free body diagram, which reveals the active forces, the direction, and otherwise. So now let's take, for instance, this is the point of application where the member forces are meeting. So for the free body diagram, I have this guy, then I have this other guy, then I have this guy. Okay, this is what we have. Now from the question, we have something like this. Then, what X? Remember that for these two sections, this weight is acting down. As long as it is weight, it must be acting downward. Then we have 850 Newton acting downward. Now remember, if this 850 is acting downward, these two members cannot be acting downward, otherwise there will be collapse. So for this object to remain in this state of rest forever, these two guys must act in opposite direction. That is to say, they definitely will be acting upward. This becomes the direction of this guy, and this equally becomes the direction of this guy. Then we can call this T, AB, tension on cable AB, and this other guy becomes tension on cable BC. So for this problem now, we will be obtaining the value for TAB and TBC. Now the question is, now that I have two unknowns with just one weight, how will I be able to obtain this unknown? What formula should I use among the formulas or the model, the mathematical formula used in calculating forces? Remember, we have Pythagoras theorem, parallelogram law of vectors, Lami's theorem, and resolution of forces. These forces that we have here, there are three. And Lami's theorem is always suitable to analyze member forces when you have three forces. So guys, we will be using Lami's theorem. I hope by now you know the reasons why we are using Lami's theorem to solve this system. It is because it contains three member forces. Okay? Contain three member forces, the weight and the two tension. Now that we have decided that we are using Lami's theorem, guys, what do we need to obtain? We need to find the angle connecting this tension to this weight, connecting this tension to this weight, and connecting the two tensions. Now from the question, the angle connecting the two tensions has already been given. Remember, this symbol is a symbol that shows a right angle triangle. So if this point is a right angle triangle, that shows that angle at this point is 90 degrees. Automatically, this is 90 degrees. I need to find angle here, and equally need to find an angle here for Lami's theorem to be used. So how do I obtain the remaining two unknown angles? Guys, is this not wonderful? Is this not amazing? Am I not blowing up your mind? Are you not gaining massive values free of charge on this channel? Now guys, let's push ahead. Looking at this, we will come back to the general equation. What do? Just create a horizontal line on C line to represent your x-axis. At this point, remember that the angle here is alternate to angle at this point, which shows that this is 60 degrees. And remember that from here to this point is 90. That means to obtain the angle between this C and this weight, I will have this guy. And what does this guy mean? It means I need to sum up 90 and 60 to be able to get the included angle between this force and this weight. So when I add 60 to 90, what will I have? This will have given us 150. That means the angle here is 150. Then I mentioned that there are other ways, there are so many ways to obtain the third angle. You can still obtain the third angle from here, or better still obtain it from here. Knowing fully well that the sum of angles acting at a point is 360. I have three angles. Now I know I can obtain the third angle using the sum of angles at a point. Automatically, I can decide to have the third angle plus 90 plus 150 is equal to 360 degrees. This plus this guy would have given us 240. So theta 3 is equal to 360 minus 240. It's as simple as this. Now when I remove 240 from this guy, I have 120 degrees. That is the answer. So that would be the angle acting at this point. Another person can say, no, I don't want to use angle at a point. This is why you just need to understand the principles. So when you understand the principles, apply the principles that you are good at, and you will always excel. You will always have it correctly, provided that you do not manipulate your way in. Just ensure you apply a reliable and notable formula or principle. That's all. You begin to see now that this course or this aspect of this engineering mechanism is very, very simple. All that is required of you is to understand principles. I hope I'm opening your eyes and I'm giving you massive values for watching this video. Now let's continue from where we stopped. Now guys, another person can say, no, let me obtain it from here. Remember, as I created this line here, angle here is already 90. But the angle I need is from here to this point. That means I need to find this small angle at this point. How will I find that angle? Remember, if here is 90, there are so many ways to obtain this small letter angle here, if as we call it x. Because for us to be able to get this angle, we need to find x. So there are two ways to obtain x from here. Number one way is you can use angle on a straight line, which shows that x plus 90 plus 60 must be equal to 180. Reason, and sum of angles on a straight line. And if I have this done, I will have that x is equal to 180 degrees minus 150 degrees. Because 90 plus 60 would have given us 150. And when we remove 150 from 180, our answer becomes 30 degrees. So when we add x plus 90, which is 30 plus 90, we have 120. Then another person can say, no, I want to find x using this angle. Remember that this is a triangle, right angle triangle. And the sum of angles in a triangle is 180 degrees. That means this is my x. Or let's assume this is y. So now remember that y plus 60 plus 90 degrees is equal to 180. Reason, sum of angle in a triangle. And automatically y would have given us 180 degrees minus 150 degrees, which is equivalent to what? 30 degrees. Now remember also that x is alternate angle to y. It shows that x is equal to y. Reason, alternate angle. Now that we know this, whichever way you follow, you always have your answer. So it requires you to understand the principles that works. Now we have fully obtained the angles between the forces. We can now state the Lami's theorem and begin to solve. Now we put down 120 degrees here. Okay, now using Lami's theorem, recall that this tension AB over sine of the angle opposite it. Now, if this is this tension, what is the angle opposite this tension? 150. So we have sine 150 degrees is equal to, the other tension is TBC, all over sine of the angle opposite the tension. So this is the tension. The angle opposite this tension is 120. Then I have 120 degrees. Then finally, I will have the weight, which is 850 degrees, all over sine of the angle opposite that. Sine of the angle opposite this guy is it's what? 90. Then sine 90 degrees. This is the standard equation of Lami's theorem. At this point now, we need to now pick two ratios at a time. Now we have three ratios, and we have 2 equal to. And remember, we can have 2 equal to in one equation. So we now pick either the first 2 ratios, the last 2 ratios, or the first ratio and the last ratio. Anyone. Now the question is, let me decide on what to find first. So if I decide that I want to find TAB, to find TAB, I will have TAB over sine 150 degrees is equal to 850 Newton all over sine 90 degrees. So now, all we just need to do at this point is to make TAB the subject of formula. If we make TAB the subject of formula, we will have this as TAB is equal to 850 Newton multiplied by the sine of 150 degrees all over sine 90. Now guys, when you input these values into your calculator, you will have an answer as 425 Newton. This is tension AB. Now very quickly, let's obtain tension BC. Is this not wonderful? I hope you are gaining massive value for this lesson. Now quickly, to obtain TBC, we will equally pick the last 2 ratios in this case, or pick the first 2 ratios now that I already obtained the value of TAB. Or let's take the 2 last ratios. We will have this as TBC over sine 120 degrees is equal to 850 Newton all over sine 90 degrees. Now to obtain TBC, we will make TBC the subject of formula. And if we have this done, TBC becomes 850 Newton multiplied by sine 120 degrees all over sine 90 degrees. And now guys, when you punch this into your calculator, 850 sine 120 divided by sine 90, the answer becomes 736 Newton approximately. This is the answer to this very question. Now this is tension AB, tension BC. You find out that in this case now, the tension varies. Why? Because they never made the same angle with the horizontal. So now let's analyze this, guys. Which tension is higher? Tension BC. Why? Because it has a greater angle to the roof level. So the one with the highest angle to the surface level will always carry more of the load. So this guy here, this tension BC, is carrying more load than this. Why? Because the load is closer to this support. That is, assuming I want to cut the center, but you find out that this load is closer to C than A. This is one of the reasons why tension in BC is more than the tension in AB. Don't forget, engineering is practical. Mind you, you need to understand these principles very, very well for you to be outstanding in handling problems on engineering mechanism. I hope by this time I've also added a fresh and a new value to your life, guys. You don't need to kill yourself. If you do not understand it as you watch it for the very first time now, you have the opportunity to replay the video as many times as you wish. Don't forget, when you keep hearing it, you will understand it more and more. That is how it works. So keep playing the video over and over again until you understand the mysteries and the principles I share in this video. Don't forget to share this video to your friends, and don't forget to like, don't forget to make your comment, and if you are not subscribed, don't forget to subscribe to this channel if you have gotten value from this. Very quickly, let's check problem number 5. Love you guys. Guys, welcome back to this session. Welcome to this new session with me. Very quickly, we shall be looking at question number 5. Yes, problem 5. Remember, we are problem solvers. How do we get to solve problems? We solve problems following principles, laws that are applicable. Now, let's look at this question. Problem 5. What horizontal force P is required to hold the 10 kg mass shown below in position? What horizontal force P? What will be the value of this horizontal force that will be able to hold this mass of 10 kg in position, meaning at rest, meaning at equilibrium? That's it. So for this load to be at equilibrium, acting down, having a tension of this guy here, there must be a horizontal force either to this direction or to this direction. But already we have it to this direction. Assuming this force is not here, do you think that this guy will stand? No, it will either swing this way or better still, fall down. So for this object to remain vertical like this, remain at this particular position, there must be a horizontal force pulling it this way. As long as the tension is acting that way, this guy is acting that way, there must be an opposite reaction. So if this object must be at rest, this guy must have a value to put this at equilibrium. The question now is, what magnitude of horizontal load will be here to suspend 10 kg mass? What will be the weight? What will be the load here? What will be the force to put this guy this way for this guy to remain here? Remember, as I just mentioned, that if this load is not here, this guy will swing that way. It will not be at rest. In fact, if I thought this object, if I thought this load is not here, this is fixed, it will be swinging. But we don't want this to swing. We just want it to remain static at a point. So the only way we can make this guy static is that there should be a force pulling this way to make this be at equilibrium. That is the force we are asked to look for. You see, you need to understand questions very well before you take the first move. In other words, we are looking at this structure, we have 3 member forces. 1 is the weight, 2 is the horizontal force, the 3rd is what? The tension. Let's assume this guy here is the roof level. So now let's work this out. The first thing we will do is to draw the free body diagram. But one thing you must not forget is that anytime the weight of an object is not given in Newton, you must convert to Newton. Or anytime the weight of an object in engineering mechanics is given in mass, there is always a need to have it converted to its equivalent weight. Remember, this is mass. So to solve, we need this to be in weight. And what is weight? So this is solution. So we remember that weight W is equal to mass times acceleration due to gravity. And the mass we have is 10 multiplied by acceleration due to gravity is 9.81 meter per second squared. 9.81 meter per second squared. Okay, but we don't need the units. Then when we multiply 10 by 9.81, this will have given us 98.1 Newton. This is the weight acting here. Now we can sketch the free body diagram. Now we come, this is the point where all the forces are acting. This is the weight. which is now 98.1 Newton. Then this is the horizontal force, P. Then this guy is the tension. Don't forget, so this is the tension. Now remember that I have three member forces. So the question now is, which formula should I use? Resolution of forces or Lami's theory? Guys, it will always be easy for you to make use of Lami's theory anytime you have three forces. So now that we are using Lami's theory, what do? All we just need to do is to obtain the included angle, the angle between the forces that we have here. Now let's take this as the tension. For this question, we are not actually required to obtain the tension. We only need the load. But in another question, you can be asked to obtain both the tension and the load. So as a result, in this question, I will help you by obtaining the horizontal load and equally obtain the tension, even though we are not asked, just to put you on the same track. I hope I'm giving you massive values, blowing up your mind, so you can become a master in this course. That's my intention, to help you gain mastery, to help you build your mental capacity. And that's why we call it master builders. So we build masters in all professions. Is that not wonderful? Be a part of this team and you will be blessed abundantly. Now let's go. So in this case now, from the question, look at this point. You find out that this is a right angle triangle. That shows that the angle here is already given to be 90 degrees. Now, we have obtained this angle here. The next is, remember that if I extend this line of action, angle here is 72 degrees. Why? Alternate angle. And now remember also that at this point, this is 90. That means the angle between the tension and the weight would have been 90 plus 72. 90 degrees plus 90 degrees plus 72 degrees. When we add 72 degrees to 90 degrees, this will have given us 162 degrees. Then this is 162 degrees. Then another way I can start to now find this angle here. To obtain the angle here, let's call this x. The sum of angles on the straight line is equal to 180, so I can have x plus 72 is equal to 180 degrees. Reason, angle on straight line. So the sum of angles on the straight line is equal to 180. Therefore, x would have given us 180 minus 72, and this will give us 180 degrees. Then you can equally say, no, I don't want to use this theorem at all. Let me quickly make use of what? The sum of angles at a point, knowing fully well that I have three angles here, and I have already obtained two. To find the third, all I just need to do is to have this guy as third angle is equal to 90 degrees plus 160 degrees is equal to 360 degrees. Reasons, angle at a point. So the sum of angles at a point is 360 degrees. If this is obtained, all I just need to do is to sum up these two angles together, then remove from 360. If we do this, we will equally have 108. Whichever way you take, you will definitely have the right answer, provided that you are applying any notable, you see now, notable theorem. The theorem we use here is angle on a straight line. The theorem we use here is angle at a point. Both theories are true because they will give you the same result, provided that you do not manipulate your way in. That's all. Now, this we find to be 108 degrees. Now that we have gotten this, all we just need to do is to state the Lami's theorem. Guys, is this not wonderful? If you are given Lami's theory problem to solve as an engineering student, will you still have issues with this? Not at all. Then I think I deserve a hand of applause. Where you are watching me there, can you clap for me? Because I am giving you values for free. Now, using Lami's theorem, remember that we are looking for force P all over sine of the opposite angle. So if I take this P now, the angle opposite this is 162. Then is equal to T all over the sine opposite this guy is what? 90 degrees. Then finally, the weight, 98.1 Newton all over the sine. Opposite this guy is what? 108. This is very simple, guys. It's simple, so simple. Very, very interesting. Yeah, it's so interesting. Guys, watch out. Other videos are loading. Lots of videos are coming up on this course to help you balance yourself as an engineering student. Then you'll be working with confidence. Now, it is a choice to find T first or P, but based on the question, we are obtaining the horizontal force. So to obtain the horizontal force, we state to find P. We will take the first ratio and then equate it to the last ratio. So we can obtain T or P. Now we have P all over sine. 162 degrees is equal to. So now we've taken the first ratio, now we need to take the last ratio. The last ratio is 98.1 all over sine of 108 degrees. Now that I'm looking for P, what will I do? I will just make P the subject of formula. And P becomes 98.1 Newton multiplied by sine 162 degrees all over sine 108 degrees. Now, when we impute these values into the calculator, we will have this answer to be 31.87 Newton. This is the horizontal load or the horizontal force that will be able to keep these objects at equilibrium. This is all about this question. But by extension, I just mentioned that I will guide you to help you find the tension. Paravector, you have equations as this, and you are asked to find both the horizontal load and the tension. I hope I'm doing well for you. Then I will deserve a hierarchy later after this class. Right? Hope that will blow up your minds. Now, quickly, we have to find the tension T. We will have this as T over sine 90 degrees is equal to the last ratio 98.1 Newton all over sine 108 degrees. Now I'm obtaining the value of T. All I simply need to do is to make the tension the subject of formula. And by so doing, T would have given us 98.1 Newton multiplied by sine 90 degrees all over sine 108 degrees. Now, when we impute this in our calculator and compute, the final answer would have been 103.14 Newton. This is the tension for this particular structure. While we obtain the horizontal force to be 31.87, now we just obtain the tension to be 103.14. Hope this lesson has added a new value to your life. Guys, follow us on all our social media platforms because we are adding values to your life for free. Subscribe if you have not done so, please. Then, don't forget to share this video. Don't equally forget to like this video, and don't forget to make your positive comment at the comment section. You stand the chance to replay the video over and over again until it becomes part of you. But if you have any question, do not hesitate to make your questions known to us at the comment section. We are good at answering questions, and we will answer them to your own satisfaction. Hope this is good offer. Now, guys, we are going to dive very quickly into solving question number 6. I know that somebody is already anticipating for that class. So very quickly, let's look at problem number 6. Welcome back to another session with me. Welcome to Master Builders. Now this is part 6 of this problem solving section. So on the board we have problem number 6. And I know you are excited to know how this problem can be solved. Now let's read the question so that we know the first step to take. A 370 Newton lamp is supported by 2 cables, AB and AC. AB and AC are shown below. AB, AC. Now, find the tension in each cable. This problem is not different from what we have been solving before. Only that you have dimensions here. Dimensions, no given angles. So what will I do? So first of all, guys, what we need to do here is to obtain the free body diagram. And to obtain the free body diagram, I will have that. Let me leave this place. This is what I have. Let's put the diagram here. I have a load this way. So for this guy, we don't need to convert because it's already in Newton. Or I measure when you have it in mass, kg, there is always a need for you to convert to Newton. Now this is 370 Newton. Then at this point I have this, then I have this. So you don't need the prophet to tell you the directions where this tension is acting. So this is T, A, B, tension AB, and this is tension AC. Now remember that in this case we have 3 forces. And for us to be able to solve 3 forces effectively, it is either we make use of Lami's theorem or we use resolution of forces. And as usual, I mentioned earlier, it is always easy for you to make use of Lami's theorem as long as it is possible to use Lami's theorem. So very quickly, we shall be using Lami's theorem to solve this very problem. But you know that you cannot make use of Lami's theorem without knowing the included angle. What's the included angle? The angle between the load and the tension, or the angle between the tensions. So we need to obtain the angle here, obtain the angle here, and obtain the angle here. How do we go about these angles? Knowing fully well that we're not given angles here. Listen guys, this is very, very easy. Now remember that this is a right angle triangle. This height here is what is given as 1. That means from this sketch that we have on the board, I have something like this, whereby this is 3 meters from here to this point, C, A. Then let's put this point as D. So this is D. This is 3 meters, then this is 1 meters. Here is angle 90. So now, what angle are we looking for? We are looking for this angle. We can call this theta 2. Why we call this guy theta 1? So to find theta 2, we use tan theta is equal to opposite over adjacent. That's all. Then we are done with that. Then for the second case, we have something like this. This is point B, this is point A, this is point D. This point, we just take this section now. This is theta 1, and this is 2 meters, while this is 1 meter. Now remember that this is right angle triangle. So you find out that the parameters that are given for the dimensions are enough for us to obtain the angle that the tension or the wire, the cable, made with the plane surface, which we would liken to be the roof surface. I hope you are here, please. Pay close attention. This is one of the reasons why I mentioned that you should not skip any part of this video, because every bit of this video is always unveiling secrets upon secrets, and you need these secrets to become a master in solving these problems. So now follow me as I hold you by the hand again and walk you through the process of obtaining angles when angles are not given. Now, coming to this guy, to obtain theta 1, we have tan theta 1 is equal to opposite over adjacent, which is 1 over 2, and this is 0.5. So theta 1 is equivalent to what? Tan inverse of 0.5. Now the tan inverse of 0.5 is 26.66, just like that. So we have this as 26.6 degrees. This is it. We are done with that. Then to obtain theta 2 using this second figure, we'll have that theta 2 is equal to 1 over 3. Opposite over adjacent, which is what? DC. Then this would have given us 0.3333. And now when we find the inverse, theta 2 becomes the tan inverse of 0.3333. And this would have given us what? 18.4 degrees. If we find the tan inverse of 0.333. Now we have been able to obtain the angle here and the angle here. Now let's take, for instance, we want to do this analysis here. Okay, this is the load, this is the angle, this is the angle, this is the roof. Now I now know this guy to be 18.4, while this guy is 26.6. Remember, if I draw this line out here as my horizontal reference line, it shows that this angle here is alternate to this angle. This will have given us 26.6, while this will give us 18.6 degrees. Now remember, the angle we are interested in is angle between the tension and the load. That would have been what? The sum of 90 and 26.6. I hope you understand it. Yes. The angle between this tension and this weight is what? The sum of 26 and 90. So we have 90 degrees plus 26.6. 26 plus 0.6 plus 90 would have given us 116.6 degrees. So here we have this guy as 160.6 degrees. Now for this other guy, remember, if from here to here is 18.4. 18.4. And now this point here is 90. That means the sum of the included angle here would have been 18.4 plus 90. Then we have 90 plus 18.4. And this will give us what? 108.4 degrees. That means the included angle here is 108.4 degrees. As simple as that. Now, to obtain the angle between the two tensions, it is very, very simple. It's either you make use of this, the sum of angle at a point, or come to this end. Remember, the angle we are looking at is this. So if we put this as x, x plus 26.6 plus 18.4 would have been equal to 180. Reason: angles on a straight line. And if this is understood, therefore we have x plus 26.6 plus 18.4 all is equal to 180 degrees. Sum of angles on a straight line. Then if we make x the sort of formula, we will have 180 degrees minus 26 plus this will have given us 45 degrees. So when we remove 45 from this, we have 135 degrees. Therefore, the angle between the two tensions is 135 degrees. Now that we have obtained the included angle, guys, what is next? All we just need to do is to state the Lami's theorem for this particular system. Then we solve for the unknowns. You find out that this is very, very simple. Now, using Lami's theory, remember that TAB over the sine of the opposite angle. If this is TAB tension, the opposite angle is 108.4. Sine 108.4 degrees is equal to TAC all over sine opposite angle. This is TAC, so the angle opposite this guy is 116.6. Sine 116.6 degrees is equal to the load 370 all over sine. Angle opposite this weight is 135. 135 degrees. So at this point we have been able to what? Extract the Lami's theorem from this question or from this figure. All we just need to do now is to decide on the tension to find first. So now let's start from tension AB. Now to find TAB, we have TAB over sine 108.4 degrees is equal to the last ratio, which is completely known, 370 Newton, all over sine 135 degrees. So making TAB the subject of formula so that we can obtain TAB, we have that TAB is equal to 370 Newton multiplied by sine 108.4 degrees all over sine 135 degrees. So TAB is equal to, now when we multiply the numerator and then divide by the denominator, we have this as 496.5 Newton approximate value. This is the answer for this tension. So the capacity or the strength of this cable AB is 496.5. And lastly is to obtain the tension on what? AC. Now to find TAC, we have TAC over sine of the included angle. The included angle is 116.6. Is equal to the last ratio, which is the weight over the sine of the opposite angle. Then we have 370 all over sine 135 degrees. Knowing fully well that we want to obtain the value of TAC, we will just make TAC the subject of formula. And to have this done, we have that TAC is equal to, when we cross multiply, we'll have this as 370 multiplied by sine 116.6 degrees all over sine 135 degrees. 467.9 Newton. This is the tension on cable AB. Now guys, you find out that all the problems that we have solved so far are principle and law based. Do you now see that you cannot gain mastery over this course, over this topic, without knowing principles? Now, at this point, have you actually obtained maximum values from this video? If not, guys, you need to replay this video over and over and over and over again until it sinks into your mental capacity. One of the things is, when you keep listening to me as I teach you in this video, over time, it will be as if I deposited the full idea into it. So guys, keep watching this video until you understand the mysteries behind this aspect of mechanics that we have actually looked at. Guys, these values you have obtained for free, will you just enjoy it all alone? Not at all. All you just need to do, guys, is to help us share the link of this video and let it go viral. Make sure your friends, your colleagues, your classmates have access to this platform so that they can enjoy what you are enjoying for free. Will you be selfish with it? Not at all. If I am not selfish, giving you all that you need for free, then why not link somebody to this page and let the person benefit from it maximally? One of the things is, if you bring somebody to this platform to learn, they will appreciate you later because you have shown them the light. Yes, you have shown them the light. Every one of us need light. Every one of us. So please, guys, don't play with this video. Please, if you watch this video, make sure you ask questions at the comment section and make sure you put down positive comment at the comment section. One of the things I will let you know is that I am preparing another mind-blowing session for beams and supports. So don't miss that video. When you watch this video, please subscribe. Turn on the post notification bell so that when I upload that video on beams and support, How to calculate support reaction, how to calculate pin reaction, how to calculate moment, how to take moment, clockwise moment, anti-clockwise moment. The use of the equations of static equilibrium will be revealed in that video. So all you just need to do to enjoy that video is to ensure that you visit this page often and often. Then you will be liberated in the problems involved in the list. Guys, I love you. I want you to share this video and I want you to give me positive comments at the comment section. Don't forget to give us a thumbs up, like this video, share this video, and do not forget to subscribe. In fact, you can subscribe your friends for us, knowing fully well that you are gaining free values from this platform. Now, guys, I will be leaving you at this point to prepare a place for you to continue in this course. I hope you will join me in that video as I will show you again another principles to use in solving problems on beams and support conditions. Love you guys. Thank you for watching this video. Bless you, bless you, bless you. See you in the next class.